dalgaları karşılayan gemiler gibi gövdelerimizle karanlıkları yara yara çıktık. Rüzgarları en serin, uçurumları en derin, havaları en ışıklı sıra dağlara. Hey, hey, hop, hop, hey, hey, hop, hop, hey, hey, hop, hop. Dostların arasındayız, güneşin sofrasındayız. Dostların arasındayız, güneşin sofrasındayız.
The working area is to be gassed with hydrogen peroxide vapour, VHP or HPV, and that's to sanitise. It's not a good idea to gas particle counters. It's because VHP tends to degrade the optical elements, bleach and counter optics. Often isolator manufacturers are asked to supply both viable and non-viable particle monitoring, and there's also some automation to take place within that gassing isolator. Isolators tend to be 2 or 4 gloved with transfer hatches, but they can vary. So, some of the considerations you have to take into account: you have your isolator, and we've introduced a nozzle here, which obviously has got a pathway back to a particle counter. So one of the first things you do, if you apply hydrogen peroxide or VHP to that isolator to sanitise, that is a metered dose for a specific time. So if you've got a pathway that can leak out besides anything else, you may not actually properly sanitise your isolator. Also, on modern isolators, you have to take into account that these isolators have to leak test, so somehow you need to close that pathway. So the way we handle that, just go through that. So the way we handle that is we need to protect the particle counter. In an ideal world, the sample path is direct. There's nothing between the sample probe and the particle counter. But what we have to do in this case is do the best we can. So what we do is we introduce a stainless steel ball valve. It's located between the sample cup and the particle counter. It rotates 90 degrees to divert the flow away from the counter. It's driven by a motor. It has micro switches at each end of this operation to determine where the ball valve is. And the internals of the ball valve are such that particle traffic is kept to a minimum. So we look at that. We have a monitoring system, and this is generally picking up all your particulate data and your air pressures and so forth. We have some kind of feedback to the operator via a form of beacon to tell them what's going on. And then we have an isolator controller which actually directly interfaces to the monitoring system. So when you select gassing, it automatically shuts the pathway off to the particle counter. What that valve also does, because the idea is you affix it as close to the particle counter as you can, so that it enables gassing of most of the pathway over sanitation. And when it's in a gassing mode, it goes into divert. So instead of the flow coming through here, it will come through here, back up here into a lower pressure part of the isolator. You need a negative pressure to get the VHP gas through. So for isolators, we have non-viable and viable particle sampling solutions. For the viable sampling, we use an active air sampler head. And the active air head are available either in 100 or 180 litre per minute sample flow rates. They use a standard 90mm Petri dish. It's simple to install. There's an alarm generated if there's no dish present, so if you forget to hit your dish, the system will tell you. There's no external vacuum required, so you just fit this and it's there. The flow is monitored and controlled. This is quite important because it does ask you for 1,000 litres, so if you don't measure the flow, how do you know you've made that sample? It's only the sample head that sits in the grade A area, if you don't want too much inside your isolator. It can be sterilised and gassed into place. The air sample is drawn onto an agar plate, built-in impeller underneath which pulls the air through. And then only the items entering the filling machine are irradiated. Sterile plates are put in barcoding bags, fixed, double or triple bagged. As we said, the sample flow is monitored and controlled in real time. The heads themselves are a 316 stainless steel that can be autoclaved, or they can be supplied with disposable irradiated heads. So with continuous monitoring, you have a PC with individual PMP software. You have a 6015 particle counter with an integrated pump. You have a ball valve. You have an active airhead sampler, and you have an active airhead controller. The airhead controller, as I said previously, controls the flow and speed of the device. The system here is fully 21 CFR Part 11 compliant for logging, alarms, trends, reports, and so forth.